Hello, friends. I'm Shankar Hemmady of Blue Horizons, and it's always exciting to talk to people who have done a lot of interesting stuff in various aspects of what we now call AI, ML, edge computing, cloud, and all the connectivity that it takes, the infrastructure that it takes to make it happen. And here with us today is Rob Aitken. Rob, it's been exciting having known you for over the years in various aspects of the entire design process. And it's also delightful to find out that you worked on expert systems way back in the 80s. Please tell us a little bit about yourself.
So sure. So as you said, yeah, I graduated with a master's degree from University of Victoria and went to work on expert systems for the Alberta Research Council, doing liver diagnostics, among other things. And then I decided, perhaps incorrectly, that VLSI was more of an exciting topic than AI. So I moved in and did a Ph.D. and EE at McGill, Montreal. That was my main topic was on chip diagnostics and built-in self-diagnostics. Then went to work at HP doing design for test and ran into you back in the day at Sunrise Test Systems. Continued to work on that at HP, and then sort of expanded my repertoire into libraries and design methodology, and worked on all of the above, and then eventually joined Artisan, doing a lot of sort of a combination of library stuff, memory test, memory design. Artisan got acquired by ARM and continued doing a lot of projects in memory. Specifically, one of the main ones was around memory statistics and the distinction between the way that you margin memories and the way that you margin non-memory aspects of circuits. Went on and did some DTCO, so got down into the device level, and then into memory, more into memory systems. Got into security and including, secure systems, which, as you know, spans the entire stack up through application software. And in 2022, joined Synopsys doing technology strategy, which, as we talked earlier, has been mainly around multi-die systems and AI in its various forms.
Oh, this is exciting. You started off in expert systems. What was it like in those days when you're working on disease models and all that? And how is it morphed over the years?
It's really tracked Moore's law, I think. So the system that I was working on, it was originally running on a Lisp machine, and then I ported it to a 286 based PC because that was faster than the Lisp machine. But it was only faster if you fooled around with tail recursion and similar software optimizations on the PC. But the technological part that it was somewhat innovative at that time was doing a confidence estimate of its own prediction. So it would take a set of symptoms and it would say, here's the most likely cause of that, and here's perhaps a secondary or a tertiary cause, and it would assign a score to it. And the score was intended to be kind of a probability, but it was hard to make it into a legitimate probability. It was more like a weighting factor. There was to give you kind of a computational piece at the same time, there was another project using neural nets for character recognition. And all of the power of a Sun workstation at that time, harnessed towards character recognition, could just barely do it in like 1 character per second timing. So that was kind of the state of the art. And whatever number, that's like close to 35 years. So that's say 15, 16 plus generations of Moore's law. That million-fold increase in compute power has changed the ability of a single machine to do AI dramatically. And then you have further data centers which are able to harness hundreds or thousands of machines in order to amplify that capability further. So really the technology of AI at some fairly fundamental level hasn't changed a lot. Neural nets were a thing 35 years ago, but what has changed is the scale of models that can be attempted. And that has led to further refinements in what kind of learning are even possible now. So that change has been exciting to watch. We're on
And
another upswing still, as you know.
yeah, I started using expert systems in the early 2000s, and it was very exciting, but just did not have the bandwidth to be able to scale up. We were barely able to do toxicity estimation of medical drugs. And it is
Yep.
exciting, it is useful, but today it is, you cannot not use it. I mean, it's that powerful. So, question for you. Um, you have tracked the whole progress in the industry. Are you currently using AI? And if so, how is that looking like?
I am, and there's I'm using it in multiple places. So I have a variety of hobby things that are AI based, and then I've been like everybody else on the planet playing with Chat GPT in its various incarnations. At work, we're looking at AI augmentation for EDA tools and for the design process in general. That aspect has largely been taking the huge amount of complexity associated with a tool. So even, even 30 years ago, back in the Sunrise days, these tools had a number of different options and you could tune them in various ways. They now have more, and there's so many different ways that you can tune them that people become experts in simply how they tune the things for a given design. But what's interesting is if you throw this at a learning algorithm and say, here's your reward function is how good this design is, based on whatever criteria of performance or area. And these are the variables that you have to play with. It's capable of tuning the knobs itself and coming up with, in many cases, it can come up with things that replicate what designers do, but it can also often come up with some combination that nobody had thought of, and that produces a better result. And that capability is, I think, EDA is one of the many industries that support it. My home project is on image recognition, which I've been playing at for a long time, which is just, I have a camera outside the house, and when somebody comes up to the door, it sends me an email. But the motion trigger on the camera is fooled constantly by sunlight and by leaves on a tree that are right outside the door and by who knows what else. So I've now, after years of tweaking it, it now is fairly stable, running through a version of MobileNet that's running on a Raspberry Pi, which again, if you look at this thing, it's an object that fits in the size of your hand, and it itself is, probably at least 1 million times more powerful than the workstation that my expert system ran on.
Yeah. Yeah. In fact, I still remember the days when we used simulated annealing and genetic algorithms and all that.
Yep.
So, given all this hoopla around how AI is going to be changing the whole world, I like the concept of what you were doing way back in the 80s, which is estimating the confidence and some kind of a measure of the quality of results. Because this whole tuning or prompt engineering, as they call it,
Mhm.
giving the right prompts or tuning it so that we still have a lot of measures, even if they are subjective sometimes, whether it's the quality metrics, coverage metrics, whatever. Do you think it's possible to do that in the context of something like ChatGPT? Is it possible to have measurable AI?
I think it's possible. In fact, I suspect that it's there, but they've just removed it from the public interface. That because if you observe it on any given problem, it's actually quite interesting the progress that it makes. So there was an example of can you write a script that does a specific, uses a specific tool to produce a specific result? And it can actually do that. It will pump out, here's a script. And then you say, terrific, I love your script. Can you make it faster? And so it'll do stuff. And then it'll do that. And it'll cycle through all of the known best practices. But then at the, once it's exhausted its supply, it will actually start making things up. So, it's basically the equivalent of a dash go faster option that it just pops, it just says this is the answer. And you'd think that buried somewhere in itself, it would know that it just fabricated that or that the source that it was using for that particular piece of predictive text was unreliable. You would think that somewhere it would know all this stuff. But I think they don't put it in the public interface for two reasons, partly just to see what we do with it, but secondly, because these numbers influence you. So, even in the 80s expert system, if it says diagnosis 99% certainty, then you, as somebody reading it, give that more credence than you would if it said, 4% certainty. And so it's changing the existence of these numbers changes your interaction with the system and makes you part of a feedback loop. And that's I think something that the existing chat GPTs of the world are trying to avoid doing. They don't want us to see any confidence factors. They just want us to try to develop our own.
And in fact, speaking of confidence factors, hallucination is a very interesting topic too, because it has to, in order to get something novel, it has to tinker around. It cannot just use existing practices. So is hallucination a bug or a feature, in your opinion?
It's both, right? So it's a property of the system. It's not really, I think labeling it a bug is incorrect. And it's tricky. It's tricky when talking about these things because we wind up, for better or worse, anthropomorphizing them and saying, well, it's thinking of this and it's plotting that, and it isn't really doing any of these things, but it's a convenient shorthand for talking about them. So at some level, like the making up the tool option is kind of like the person on the other end of tech support who's tired of talking to you. And so it just gives you some nonsense. Not that any company that either of us have ever worked for would have tech support people who did that. But at some point, it's just like, please go away and stop asking me questions. And some of the hallucination mimics that. I don't think it's the machine doing that, but I think it's exhibiting a property of human beings that, if pushed at some point, you have to either give up or start making things up. And then the machine is trained to, most of the time, not give up, to just keep plowing ahead. And as you said, that gives it the opportunity to come up with something and to mimic creativity at some level. So hallucination is a means of mimicking creativity. But I think, like so many of these automated things, it's not really creativity in the sense that we think of it, but it might be a precursor to it.
Yeah. In fact, it reminds me, sometimes I give prompts like, okay, tell me more elaborately, go into details. It gives a lot of details. Okay, now summarize it. It shrinks it again and then details again. So
Yeah.
it's like simulated annealing of some sort, where you're trying to, compress, decompress, and you get something different each time.
Yeah. Have you read, there was a Microsoft research paper that came out about a week ago where they put it through its paces and they were testing it out on different things and comparing GPT-4 to ChatGPT, original.
Oh, yeah. Tell us more about it. I read something, but I didn't quite grasp it.
Oh, okay. So they went through a whole bunch of scenarios just to see what it was good at. And of course, since I was originally a test person, I'm much more interested in what it's bad at. So what does it do
All
poorly?
the corner cases.
Yeah, and so one of the things that there were two that struck me that were interesting. One is that on strict numerical calculations, it's often wrong.
That's true. It's a
And
language model.
right. And I think, and you say, well, yeah, I can't do language models, but of course it could trivially. It would just say, oh, this is this is a math question. I'm going to feed it to a calculator. But again, it doesn't do that because that's not what its goal is. Its goal is not to give you the right answer to math problems. Its goal is to interact with people and see what happens. But so that was an interesting example. But the more interesting one is that it has trouble with things that require it to plan ahead because of the nature of what it's doing. So they had an example of write me a poem where the first line is and the last line use the exact same words but in reverse order, and they have to be both sentences have to be grammatically correct, and it would invariably start without thinking through really thinking through the answer. So it would wind up getting stuck having to reuse the reverse of its first sentence, which wasn't really very good and often wasn't grammatically correct, because this planning ahead process is not really part of what it does.
Wow, exciting.
Yeah.
So,
on the other hand, it's very good at manipulating. The other example there was they had it talking to a pretend child, and the pretend child didn't want to climb the big tree because, but all the child's friends were saying, you have to climb the big tree. And Chat GPT just basically manipulated the child into wanting to climb the tree, which was potentially very dangerous.
I've heard that it can take meeting notes and remove the cuss words and put in good language too. So people can continue being as as crazy as ever, but politically correct. And
yeah, if you Google the political record for Canada back in the 70s, the current prime minister's father was on record as saying "fuddle duddle" in Parliament, which
oh,
was not what he said.
oh, okay. So, which reminds me that as we get into all these interesting scenarios where things are even made up, there is that risk that somebody can actually tamper the system. It's easy to sneak into these kinds of systems. So, does cybersecurity become a much bigger problem? And I'm turning to the infrastructure side of things. Do you think it's possible to have the kind of security we need to have confidence in these systems, especially when you're working on, say, defense or some important medical systems or something like that?
Yeah. I mean, as you know, there's dozens of examples of fooling these systems via any number of means, including bad training data and customized training data, which is an interesting one because the models are so complicated. You can actually train it so that on it, effectively the equivalent of a Trojan, where there's a very specific input that produces a very specific wrong output, and the rest of the system just behaves correctly all the time. So that the existence of hidden backdoors and things are certainly a possibility, but the can we trust them piece, I think, is really interesting because we've already demonstrated even the absence of security flaws that you can't really trust them, that they need augmentation before we can trust what they're saying and not be sure that they're hallucinating. So it's a bad analogy would be in chip design. You need to have a verification process, and the verification process needs to be somewhat independent of the design process so that you can verify both this thing does what I expect it to, is the usual verification piece, and the security piece is this thing doesn't do anything I don't expect it to do or I don't want it to do. And so there's a piece of effectively understanding the intent behind the questions and the intent behind the design that I think we're going to have to be better at specifying what our intent is, so that whatever these systems pop out, we can conclude, yes, this matches my intent or it doesn't. And then you're right, we also need a bunch of technology to make sure that the nets and the models haven't been corrupted in some way for whatever goal, whether it's a goal of producing incorrect results or just hacking it, or whether it's a goal of creating an actual security flaw.
Yeah, yeah. I think we are at the very beginning of this whole revolution.
Mm-hmm.
You also pointed out something very interesting, which is the large language models are not here to give you mathematically accurate results. But we know that for years and years, we worked on mathematical models, whether it's formal models in
Yep.
verification or synthesis using design, which are totally mathematically correct and provably correct. That's how you can make new generations of chips and systems. Is it possible to have hybrid AI, which has language to interpret linguistics, and to have a backend numerical or optimization engine that'll give you mathematically correct as well?
Oh, I think so. I think that would be. I bet you that the people at OpenAI could add that to their system in an afternoon. I don't think it would be a hard problem. I think there's the challenge in. Well, let's back up a little bit. There's already systems out there that will generate mathematical proofs for things, and they're used periodically. But my son, who's doing graduate work in math, was telling me that they're not very popular among mathematicians, and not just because of the cheating aspect of it, but because of the prettiness aspect of it. That they tend to produce proofs that are not aesthetically pleasing to readers. So they produce pages and pages and pages of stuff. And then it's so complicated that no one can actually read the proof and understand it. You actually have to have a different machine check it to see. And so you wind up in this state where you have a bunch of machine proofs that nobody intuitively grasps are correct. And that's a dangerous state for theoretical math to be in, because they could all, fundamentally, they could all be wrong at some level for all anybody knows. But there's a difference in the design automation view, where at some fairly fundamental level on a 50 billion transistor object, nobody really understands in detail how all of it collectively works. Individual people understand little chunks. So the fact that a theorem prover produces a stream of gibberish, or that says, yeah, this thing is correct, or fails to produce a counterexample, or whatever you've asked it to do, all of that is an important aspect of verifying that a chip does what you think it does. It's still, 10, 15 years ago, people were having arguments about whether formal verification would eclipse other forms of verification. And I think 15 years later, I think everyone now agrees that that was, in fact, the wrong way to look at it. That formal is able to identify a certain class of problems quickly and to provide a certain level of confidence of that a design works. But it's also not complete in the sense that it doesn't cover everything that you want a design to do. There's things that you still have to do via simulation. There's things that you still do via library design and characterization and so on. So verification is a hard problem. For circuits, mapping that to AI world, I would assume that there's a similar set of analogies. There's some level of formal analysis that's possible on models to say, yeah, this model seems like it doesn't have any of a certain class of nasty properties. And there's also just usage proofs. So all of that stuff I think is fine. The piece that I'm actually wonder about is it's the case that human beings learn as we go through life, that there's various ML systems that are capable of augmenting their own behavior over time. The question that I think comes up is, to what extent do we want to use those? Because those are the ones that are much more likely to be corrupted. So it's much more likely that a system put in the field, given stimuli to augment its training and to update its learning capabilities, that it's going to go astray more than just the base model that was sent out to everywhere. So that, that goes on to your intelligent edge thing. Should the things at the edge learn or not? Give you both sides of the argument.
Yeah, in fact, I remember you and I have explored how these kinds of things can be used in oil exploration.
Yep.
And there's a lot happening at the edge there. Different oil fields have different things going on. Same thing in mining. So learning at the edge is necessary, but the question is, how do we then combine it together, and how do you keep it secure, and
how do we make it positive? And similarly, for a self-driving or even a driver assist system on a car,
exactly.
The more it learns about things, the better it will be able to handle your neighborhood. But the more likely it is that it's learned something that's just actually problematic somewhere else.
Oh yeah. If it learns to drive in India, it may learn certain bad habits.
Yep. Even if it learns to drive in the Bay Area and drives in LA, there's different driving strategies there too.
Exactly. It could confuse the heck out of those drivers.
There's also for IoT systems. I mean, I was telling you about my home camera system. So that the mobile net that it's using has 99% accuracy in image classification on the set of things that it recognizes, and person is one of them. It's got 40 or so things that it can recognize.
And that's the key. The only on the set of things that
right. But the other key is the 99%, because one of the objects in the field of view of my camera is a light fixture. And under certain lighting conditions, one of the 1% inaccuracies is the shadow and that light fixture together, it thinks are a person, and it flags them every single time that the sun gets to that point, because the thing with 99% accuracy is not like you roll the dice and 99% of the time it's one way. It's this specific input causes this specific wrong output every single time, guaranteed. So
it's predictably incorrect.
It is absolutely predictable. And so in order to exist, have the system not fail all the time, I wound up having to hard code it. It just says, if you see a person in this piece, it's not there. That's not a real person.
It's a ghost.
So I ran into at one of the AI hardware type summits, I ran into somebody who had a company who did this for a living. And so he deploys these systems in factories worldwide. And I said, okay, I have observed on my primitive camera system this being a problem. I am imagining that you have encountered this problem, and what do you do about it? And interestingly, his answer was, yes, I have, we encounter this all the time. And yes, we hard code around it because there's no other option at the moment.
Which reminds me, there's all this talk about full self-driving cars and completely autonomous systems. Given the limitations that you've seen, are we anywhere close to having full self-driving or fully autonomous systems that will self-propel themselves and take care of these kinds of aliasing issues, hallucination issues?
I think it's interesting where we're at, because we're in a state where self-driving vehicles can do a lot. I mean, they can do taxi services. They can, people, take their Teslas or whatever, and they drive them to work. They do lots of interesting things, but I don't think they qualify as full self-driving level 5 now. And I actually don't think they will for a long time. Because I think there's, as someone put it to me once, it says, human beings aren't really, capable of driving in all situations either, despite our egos claiming that we are. But the thing that with any automated scenario, this guy was telling me, he says, no matter what it is, just add stuff to it and eventually it breaks. It's like the hallucination property. So, all right, it can handle this scenario. Okay, well, now make it dark. All right, now make it rainy. Okay, now add a dog. Now add a dog and a pedestrian. So, just at some point you're going to break it. So that the end result is that additional driver automation is going to show up and it will get better and better over time. But I think it actually has to come close to solving general AI before you can do an absolute level 5.
True, true. So at least we are some ways off. All this, the hype notwithstanding. Since you worked on infrastructure in the hardware space, how soon do you think is it possible to scale? Moore's law is now getting more and more difficult without using chiplets and heterogeneous systems. What's your prediction on whether we'll be able to continue the momentum we've had on the hardware side to make some of these things possible?
I think we will for a while. And it's this. So the thing about Moore's law that's fascinating is it's an incredibly, in addition to being, a very cool prediction that, Gordon Moore was very prescient in coming up with it a long time ago, it's also been astonishingly powerful as an economic motivator. That because people expect technology to get better and better and better, there's a drive behind it. And that, I think, is going to continue. So when you look at the transistors themselves, we're now into, they get labeled as small numbers of nanometers and angstroms and what have you. But the fact is that they're not actually shrinking very much, that they're not really getting smaller. And especially SRAM cells are a good example, that the bit cells are not really shrinking because they're kind of as compact as they can be with existing types of transistors. So maybe somebody will invent some new thing, and there's a lot of economic incentive to do that. But I think what's more likely is that we'll take the technology that we have and the transistors that we have and start putting them together in more clever ways. And so we've already seen that. We've seen that really, I think, on two fronts. So the data center is one where building really truly massively parallel systems is now a reality. So those things have, if you program them correctly, they have the ability to deliver monstrous levels of performance with huge amounts of data. So that's one vector that I think will carry on. The second one that you mentioned is integration at the chip level. That if you can't pack more devices onto a transit or onto a chip, then you need to start stacking the chips up in some ways in order to squeeze them into keep squeezing them into a volume. And I think we'll find over the next decade or so that Moore's law changes from, it's gone through a few iterations, but changes from transistors per chip to transistors per volume. And that will continue to shrink as we're able to squish more in. And 3D NAND is a precursor to that, but I think we'll start seeing that all over the place.
Wow, we've covered a whole bunch of topics here, and I truly appreciate you sharing so freely. What's happening to careers? What's happening to the, what is the future of work itself with all these changes? I know you and I will retire soon, but what about the rest of the
I'm going to paraphrase a quote from it was back in the 80s when somebody said, the future of the world should be left to people who have a stake in it. And so that the future of work should probably be addressed by people who have more of a stake in it than you and I do. But I think there's a couple of aspects to it that we've already seen. So over the last 10 to 20 years, we've now seen that there's not really any geographic imperative associated with any kind of work. So in other words, if you're going to compete for a job, you're going to compete with people in your town, across the country, across oceans, across the world. Everybody is all competing in tech space, especially for the same job. So if you're going to do whatever career you're going to do, you need to be good at it. And if it's going to be a career that can be done anywhere, you need to be world class at it. So that's one piece. There's a related piece to that, which is, for the moment, there's still a few careers that have to be done locally. So dentistry is an example. You don't want dental robots are not at the point where I would trust somebody driving it from far away. Some actual dentist standing in the chair is going to be doing that. But the AI piece is another part. So now that we've seen that these large language models can generate all kinds of text, a lot of jobs that were previously effectively generating boilerplate type text are going to change. And that's going to be from everything from, writing documentation for the programs we all love, to writing legal contracts. Machines are going to be perfectly capable of writing the bulk of them. So the job of lawyers and legal assistants will go into, what's the actual unique content of this and what are we trying to protect? So there's a whole pile of stuff there. So I think the short answer to your question is, the future of work is going to be coexisting with AI, not trying to go around it.
So in other words, some kind of augmented intelligence rather than replacing humans completely.
Yeah, exactly. So humans are creative and will figure out ways to add value themselves. And so, any individual needs to be part of that process of figuring out how you're going to add value, not how just saying, well, ChatGPT took my job, I guess I'm done. You can do that if you're 70. You probably shouldn't do that if you're 22.
That was the fear. I remember in 1984, or even when we started in our industry, that synthesis and automation would eliminate jobs that were reserved for humans. And guess what? We have more work now than ever before.
Right. It changed the jobs. It didn't eliminate it. So the number of people who do gate level schematics is far smaller than it was in the old days, but the number of people who do logic design is far bigger. So
far bigger, and process controls and everything.
Yep.
Our cybersecurity, functional safety, you name it. Bigger problems. And well, with this exciting note, I would like to conclude. And do you have any? I truly appreciate what you're doing, Rob. And it's exciting that you are the consumer of some of your own technologies and you're trying to make sure it actually works.
Yeah, exactly.
Before sending it out to the rest of the world. And that's truly remarkable. So again, we'll be talking about more such things. Thank you all for listening. If you have any topics in mind that would be exciting, or people that I could talk to, please let me know. Have a great rest of the day.